All right, guys. So let's talk about this Unit 3 test review number 2. This is definitely a secondary test review. I told my students test review number 1 is definitely the one to focus on for the test, but you probably do need to know how to do this. Format, though, is much more similar to test review number 1 for the test. So let's talk very quickly about these kind of first questions on the first page. The data analysis on the second page is going to take significantly longer. All right, so if we want to write an open question and a closed question. So an open question is a question that does not limit your answers. It literally, like if we're trying to determine the most popular show on TV, we literally would write something like, what is your favorite TV show? And I'm leaving that open for like the whole worldwide of answers, like whatever you got. Excuse me. A closed question, on the other hand, limits down your answer choices. So something along the lines of, given the following choices, oh my goodness, sneezes. Given the following choices, what is your favorite show? And then you give choices. You can give 3 choices, you can give 20 choices, who knows how many choices, but you give choices now. So maybe you write something like CSI, or you use like Grey's Anatomy, or you use something like Survivor. And however many choices you want to give, but you've only like given them a specific number of choices to choose from, and so it is closed. You may not actually get their favorite TV show. You're going to get it, though, out of the list you gave them. Now, question 3, what is natural variability and what is induced variability? Okay, so natural variability is basically an act of nature caused this. So like an act of nature, a few years ago where we had that blizzard, Georgia just doesn't see that sort of snow. It was an act of nature that we got that much snow. That's a very different data point, a very spread out data point in comparison to like a normal year of snow. So like an act of nature is something that isn't man-made, isn't induced, isn't created. So induced variability is more the idea of it's a man-made or it's been a manipulated variability. So the example that I have used in my classes is if your teacher, gives you tests all the way throughout the semester, and then the last test of the semester, they say, you know what, this is open note. Those test grades are going to be much higher, typically, than the other test grades. That's a spread that was induced. That's a spread that was man-made. Not good, not bad. We're not judging about it. We're just saying it would spread the data by something that was created, not an act of nature. Okay, so those are the differences between natural variability and induced variability. Now, benefits of randomly assigning treatments to participants using a control group, having a double-blind study. So all of these kind of like roll into one ball for me. They're technically different things, but they're all kind of the same thing. We tend to use these in experimental studies. We're having a representative group, a representative sample is either money prohibited or time prohibited because it's just too hard, too long to get it done. So when we do these kind of things in conjunction with each other, the benefits of this would be it creates a reliable set of data even if your group is non-representative. Now, the easiest way I can explain why we would say it's reliable is because if the participant doesn't know what group they're in, what they're getting, and the researcher doesn't know what group this person's in, what they're getting, they're just kind of giving the participant something, the participant is just doing something, it eliminates the idea that the participant is going to lie to you because there's really no motive to lie to you. The participant may be getting a new medication, the participant may be getting a sugar pill. If they don't know, how are they going to kind of lie about what's happening with them, because there's no expectation of an answer or a specific answer. So basically our benefits are using these create this reliable set of data, even if the people aren't representative. Okay. Now our 5 data values to get a 5-number summary. This is pretty simple. It's the minimum, it's Q1, it's the median, it's Q3, it's the maximum. Those are our 5 favorite things we can find on a calculator when we start talking about all this. And what does a histogram show? Again, this is more of a vocabulary idea. A histogram shows the frequency, not an E, frequency of data values within specific intervals. So how many values lie between 5 and 10? How many values lie between 10 and 15? How many values lie between 15 and 20? The frequency of those values is what a histogram shows. And it shows them using bars. Now, speaking of histograms, let's go ahead and start talking about 7, A and B, and then 8. So if you take just a second to look at those, hopefully you've already looked at them. On 7, we're going to be creating a histogram and a box and whisker plot for sets of data. On 8, you are going to be finding the 5-number summary, the standard deviation, and the range for those sets of data. So I'm kind of going to do like 7A and 8A at the same time because they're all the same set of data, and then we'll come back and we'll do 7B and 8B kind of all together. Now, to do this, I highly, highly recommend that you have a calculator. Okay, so you definitely need to have a calculator available. So get your calculator, whatever calculator you're going to use, you're going to need to get to your list of data. So I don't know if you're using a TI-30 where you would just press data and be able to start entering in, or if you're using a graphing calculator where you're going to press stat. So maybe I'll write that down. Okay, so, this is zooming in all over the place for me. Okay, so if you're using like a TI-30, you're going to go to list. Nope, not list. You're going to go to data. Sorry, I'm not looking at one in front of my face right now. And you're going to be able to enter your list. If you're using a graphing calculator, you are going to go to stat, and then you're going to go to edit. And that will allow you to put your list in. So pause this video while you put your own list in. I'll give you a second to get that list in. Now, with this data, when you go to do these stats, and I'm jumping the gun here, we're going to start with the box and whisker. I'm already on a roll. Okay, so when you go to do these calculations, you're going to go to, I believe it's just second data, which will be your stat option. and you're going to choose one variable statistics. If you have the graphing calculator, you are again going to go to Stat, and you're going to go over to Calc and do the one variable stats. So depending what type of calculator you have is how you enter all this in. All right, so for this first set of data, get this in. We got it. All right. The parts that are going to be important for you. Down here at the bottom, let me start with 8A then. Down here at the bottom, it asks for the 5-number summary. Your 5-number summary is your min, Q1, median, Q3, and max. Now, typically those are not visible, but you need to arrow down. So your 5-number summary for example 7A, which leads into 8A, 1.7, 2.3, 2.6, 3, and 3.5. There's your 5-number summary. Your standard deviation, that is also in that list of numbers. Your standard deviation is SX. So your standard deviation is 0.485. Now the range is not in that list. The range you have to calculate yourself using the maximum value minus the minimum value. So in this situation, your range is 3.5 minus 1.7. So your range is 1.8. That is nowhere on your calculator. You must know how to do that yourself. Now I'm going to take this 5-number summary and I'm going to go up and do the box and whisker plot for 7A. Okay, so we have our 5-number summary. Our box and whisker plot, sorry for the zoom. All right, our box and whisker is a 1-dimension graph. You are going to want to put a scale along the bottom so that you can basically put your 5 numbers in the correct location. Now this data starts at 1.7. I'm going to start with a scale at 1.5, 2, 2.5, 3, and 3.5 happens to be my max. So as long as I've got those values, I should be able to put my numbers in. You're going to put in the minimum as a dash above this, right? So about 1.7 is right here. Your Q1 is 2.3. I would say that that's about here. Your median is about 2.6. I'm going to put that about here. Your Q3 is on 3. And your max is at 3.5. You don't have to label what each one is, but I wanted you to see. You box in the middle and then whisker to the minimum and the maximum. There is a box and whisker plot for that set A data. Now, what I skipped over was the histogram. Let me go back to it. The histogram is 2-dimensional, and we do expect labels to be put on the dimensions. The label for the X dimension, right, that horizontal, is basically whatever the data is talking about. The data is talking about GPAs. So our X is going to be GPAs. The Y-axis is always on a histogram, the frequency. There's no debate about what you call the Y-axis. The Y-axis is the frequency. And you just need to choose appropriate scales. Frequency is the easiest one to choose. It's just how many data values do you have within whatever you're saying. So if we're going to do the frequency, we'll probably go by ones for these GPAs. Let's start looking. For the x-axis on the GPAs, you have to decide the appropriate intervals for your bins. Now, you can do these like a number line if you would like to, because histograms do run right into each other. Like, there should not be gaps unless there's a gap in the data. These are not freestanding bars. They're like stacked right next to each other, attached. So GPAs, you can kind of do it as like, here's a 1.0, here's a 2.0, here's a 3.0, and here's a 4.0. You do have to have a specific interval, and you have to stick with it every time. If you want to go by 0.5s, you can. You can go by whatever you want to. Don't make it weird on yourself. Don't do like 0.73. That would be a weird interval. You also can actually write out your interval. The only thing I don't love about doing it this way with the number line kind of situation is if we had an exact, say, 2.0, which bar does that go in? 2.0, does it go in the bar that attaches 1.0 to 2.0, or does 2.0 go in the 2.0 to 3.0 bar? So you have a little bit of ambiguity there. So you can write it as an interval if you would prefer. Just as long as you're consistent in how you're doing this, I think you're going to be okay. This is about frequency. So I'm looking for anything that's starting with a 1, and that's going to be in my first bar. So there's only one value that starts with a 1. So I'm going to put a 1 bar, right? It's just 1 up. Now for 2s, let me see how many I have that start with 2s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10, so I need to get up to 10. Oh my goodness, I only have up to 7. So based off my scale, 8, 9, 10. Here's 10. The second one, it starts right where it was. See, no gap in between those bars. I want them stacked right on each other, unless there was a gap. If there was literally nothing between 2 and 3, you could leave a gap. Then I need my 3s. Let's see, 3s. I have 1, 3, 2 3s, 3 3s, 4 3s. So I'm going to put a bar, again, stacked right up next to it, right here. And there would be, going by an interval of 1, would be my histogram. Now, as I've been telling my classes, the interval is not overly important as long as it's consistent. So if you go to 1 to 2, the next one should be 2 to 3, 3 to 4. So our graphs can look wildly different if we choose a different interval. If I had chosen 0.5, this is a very different looking graph, because I would go with the frequencies by 0.5s. It doesn't look the same. It doesn't mean it's right. It doesn't mean it's wrong. It just doesn't look the same. So know that there's more than one way to do a histogram. It is important you label your axes. It is important that you pick a consistent scale on both axes. And other than that, just get me your frequencies. Don't put gaps unless there's legitimate gaps in the data. We're going to very quickly do B because it's all the same thing. Okay, so I'm going to I'll start with the histogram this time. Remember, I want it labeled. So we have frequency up the side. And then we're going to have scale along the bottom, and it's for times, race times. Let me rewrite that so you can read it. Times, and you might even put in minutes, as long as there's some label that we understand what's happening. So let's see, maybe start at 18. Let's go to 20, to 22, to 24, to 26, to 28, to 30. I'm going by 2s. You can easily go by 3s. Had a lot of students in class that were going by 3s. Just looks different. It's not right, it's not wrong, it just looks different. Then we have our frequency on the side. All right. So let's start with it. 18s and 19s. 18 and 19s, there's 2 of them. Okay, so there's my 18, 19s for my 20s. 20 to 22. So anything that's 20 or 21. There's one that's in a 21 range right here. 22, 23 range is 1, nope. 1, 2, let's see, 2 again. All right, starting at the 24 range, we have 1, 2, 3, 4, 5. We have 5 for the 24, 25. So 24, 25, 26, 27. 26, 27, we have 3. Right, notice I'm not putting in any sort of gaps unless there's a gap in the data. And then 28, 29-ish is going to be 2. If you go by 3s, this looks different. It's not wrong, it just looks different, and that's okay. All right, so the last thing to do is get all these 5 numbers. Go ahead and put that data into your calculator again, the same way I told you, right? You're either going to press Stat, Edit to get your data in, then go back to Stat and go over to Calc. Or you're going to press Data to enter your data in, and then press Second Data to get to the statistics. You're going to do the 1 variable statistics, and we're going to be able to talk about the rest of this. So pause this until you get that done. All right, so hopefully you're done now, you're back. I'm going to go and fill in the data down here, and we'll come back and do the box and whisker. All right, so same thing, we needed the 5-number summary. Okay, the 5-number summary for this one, I'm going to arrow around, is 18.32, 22.34, 24.56, 26.44, and 29.58. The standard deviation, again in my list, it's labeled as S, right? 3.108 or 3.11. The range, I must physically do the range. The range is the maximum, 29.58 minus 18.32. It is 11.26 is my range. Okay, so you must do those. Now, these things, these 5-number summaries go back up to the box and whisker, so I'm about to go back up to the box and whisker. Okay, so back up to the box and whisker, we want to put a range on it. So 18, 20, 22, 24, I made these a little too big, but we'll work with it, 28, and then 30. And we're just going to start putting in our numbers, right? 18.32, we have 22.34, we have 24.56, we have 26.44, we have 29.58. Box the middle, whisker it out, and there's our box and whisker. Hopefully this video helped a little bit with trying to figure out how to do all this data representation. Again, my recommendation to you is that you definitely, like, doing this is good practice. It's stuff you need to know. But test review number 1 is the one that will most closely resemble the actual test. So if you have not done test review number 1 yet, or you are still confused, I highly recommend you look at the other video for that one, and or come in to see your teacher early before the test so you can get some answers and get it figured out. Good luck, my friends. You'll be great.